Welcome to Wildcat Career Chat. I'm David Bennett, the engineering teacher here at Central High School. And today I'm speaking with an electrical engineer and an old friend, Jared Ervin from GIS.
How you doing?
Hey. So we're old friends. We went to college together and we were friends before that as well. We were friends in high school. But
Yep.
I know why I went to LSU for engineering, but why did you decide to go to LSU for engineering?
Because tech was out of the question. I told my old man I want to go to tech, and he said, "Welcome to LSU, son. It's closer, it's cheaper." I said, "Yes, sir. Since you're paying for it, I will go to LSU." And
Yeah.
actually, it was a real good experience. So
Yeah, it was a good school. We both enjoyed it there. So, what's your job now? What do you do now?
So I am the electrical and instrumentation department manager for GIS Industrial Engineering.
Okay. So, when you say electrical and instrumentation, what does that mean to a high school kid? Like, how could you explain that to us?
So electrical is anything to do with power. So the lights, your AC, anything that requires a cable and electricity go to it, that is electrical. And then there's a lot of subsets around it, way more than you ever thought possible. And then instrumentation is the way that we interact with a process to measure and control it. Think of water purification. How do you manage water flow or measure the pH of something, or how fast something's moving, level, pressure?
Okay, so the electrical end is like the how we get the power to the plug, right?
Yep.
And then the instrumentation, when you say instrumentation, it's like sensors, right?
Sensors and automation, so input and output.
Inputs and outputs.
Yes.
So that's where I worked, was in the control systems world. So we took inputs and outputs from some chemical plant somewhere, the field, and then we did something to them and turned on a valve or whatever. So you work on both of those things.
I work on both of those, and instrumentation actually goes a little further than just the transmitters and the actuators. It's actually the materials, how they interact with the process and the other metals, so actually selecting the valve body and all this other stuff.
Right.
Mechanics, chemistry, stuff that I wasn't interested in is now being pulled back in.
Yeah. Right. So so when you first finished college, where did you go? So how did you end up where you're at now? As you said, you were what was the position again?
Oh, department manager?
A manager, right?
Yeah.
A department manager. So how did you work your way to there?
So let's see, graduated in end of 2011, started working in 2012. Before all that, I had an internship, or co-op really. An internship is 3 months. Co-op is 6 months. And actually some internships go from full-time to part-time and continue. So we've got interns with us now that have been with us for 2 years continuously, working part-time through school. I had about 2 years with 2 different companies total. Then went to a company in New Orleans, worked for them for about 3 years, doing power. And when you start off, it's kind of menial tasks. I think the very first thing I had to do was size power cables. And you learn how to size power cables, and you learn how to do the calculations, what other factors to derate it. It's great. Now do this 70 more times. Oh, well, that sounds terrible. Let's use Excel.
Yeah.
Oh, I don't know how to use Excel. Let's learn how to use Excel and build something so I don't have to keep relearning how to do this or do it by hand. But so you start off doing these menial tasks. You don't even know what job you're working on half the time. This is your task, this is what you do. And then as you progress, well, here's a job you're working on until you become a lead, and okay, here's your job, get it done, and then you start getting people under you. Here's your job, you're a team lead, work with these designers, make sure everything gets done. And then management, once you kind of prove that you can get stuff done right, and lead a team of people, have good communication skills, then you step up into management, or you get promoted because they were out of options.
Oh, yeah. Which was the case for you, obviously.
Obviously, that's what happened for me.
Yeah. So, so when you first started, you said you were given very specific tasks. Size this cable, do this particular thing, and then as you progressed in your career, you got to see a broader picture of what the project actually was. So, we're building this building, so we need to connect all of these cables together.
Right.
Okay, and then eventually it's not just designing the thing, doing the engineering part, but now you've added on I need to make sure that Steve and Joe are working together to design the thing that I ask them to do.
Correct.
And then, and so you kind of start from the very small part of the design, and then you've just zoomed out.
Yeah, I mean, to whom does well in small things does well in bigger things, right?
Right.
And to more responsibility is given.
Yeah, that makes sense. Makes sense. So, let's talk more about school for a little while.
Okay.
So you mentioned that you started out with power. When we were in school, there were kind of like different concentrations, right, within the electrical engineering department. So let's just talk about some of the different directions an electrical engineer could go.
Okay.
So one of them was power, and then I had I tended to go towards, or at least after I graduated, I had the control systems thing. What other things do we remember that?
Oh, there were so many that LSU didn't focus on because it's such an ag-heavy school, and it's not a ding against LSU. It's what we need in Louisiana.
Right.
So power is obviously the big push.
Yes.
Then control systems was every third semester. So I was actually trying to focus in control systems.
Okay.
And then when someone offers you a job in power, you say, yes, I like money.
Yeah.
And it
right.
works out. It's
Yeah.
all good. The other things I was interested in was like signal processing and radios and stuff like that. So communications is one of them.
Yeah.
There's plenty of companies that do that just do cell towers and all that are responsible for the Superdome. And you don't think of the Wi-Fi networks and everything that's inherent in buildings just to keep your cell signal so you can watch YouTube.
Right.
Printed circuit board design.
That was a cool class. Did you take a circuit board design class?
Nope, I didn't have time. I was struggling the whole way through.
I took one. It was really quite interesting to build the circuit because you're making like little layers to try to build your circuit. It was a neat class. So.
What I do remember from like RF signals is circuit board design is a lot like transmission line design.
Okay,
just on a smaller, because your frequency is so high, you have all these losses in the refraction stuff to worry about that you have to worry about on transmission lines that are miles and miles and miles because it's such a low frequency. The distance is further. On a higher frequency, it's shorter, but it's a lot of the same principle.
Yeah, you wouldn't think that there's a lot of overlap between a circuit board and a power line, but
Right.
there really is. I mean, it's the same concept, just on a different scale.
Yep.
Yeah, that's a great point. I hadn't thought about that in a long time.
Yeah.
Yeah. So you also mentioned that you took an internship while you were at school. So walk me through, what did that mean for you? How did that work out?
Oh, my first internship was not as fun as my second. It was both meaningful though. So I think what most companies want from an internship is to let you get used to an office atmosphere. The first one, for half of it, I was working with the designers. I got to see the plan drawings for doing grounding, doing some voltage drop for lighting. It was more design driven, which is not a bad place to start, to know what you're looking at. Then I said, I'd like to do some engineering, please. And they put me on another project who said, you're going to do area classification. I said, great, what's that? He said, well, it's this thing that has to do with chemistry and pressure, and you tell people if there's gases that go boom in the area. That sounds like a bad idea to give an intern. And sat on that for a while, and while he was too busy doing a whole lot of other things to help me, that part of the experience was not wonderful.
Okay.
And that was the first one. The second one I had was in a panel fab shop that built PLCs, programmable logic controls.
Okay. Yeah.
And if you can read a drawing and wire stuff up and nail and screw and drill, it's wonderful because here's your drawing, here's your materials, build this.
Okay.
And yes, sir, you build it, you wire it up, you put in tags, and you get to see how something's made.
Yeah. So as an intern, you were actually getting to touch the equipment. You weren't just designing it, you were actually putting it together.
I definitely didn't design it. I was not qualified or
Right,
competent to design it, but I could build it.
You could put it together, right?
Yeah.
So more of that building from the bottom up, right? You start from the more simple tasks, and you get to work your way up as your career progresses.
Right.
Whenever you finished school, did you go after any licenses or any certifications or anything like that?
Yeah, so the first piece to be an engineer in Louisiana, so there's legal, and then there's what everyone kind of just generally accepts. People will call you an engineer once you graduate and have a degree, or if you're a sanitation engineer or train engineer. But in the state of Louisiana and most states, you're not technically an engineer unless you're professionally licensed.
Right.
And the only time they really care about that is if you have to be the engineer of record and stamp something. Then you better be licensed.
Right.
So the first steps is at the end of college, before you graduate preferably, is go take the Fundamentals of Engineering exam.
Yeah.
And it's changed since you and I were in college. So it used to be you get this book with all these reference formulas, and you get a Scantron, and then you go to a big hall, and you sit next to one other person who's not in your field. And the first 4 hours is general chemistry, bio, anything and everything for everybody. And then the next 4 hours is 60 questions just in your field.
Okay.
So the first 4 hours was wonderful because you got 7 circuits questions that you're done in 30 seconds. And then that was the end of the fun part of 120 questions.
Right. Yeah. So it's a to get the FE exam. You've got to study not only your area of expertise, like electrical engineering, but you also have to have some understanding of mechanical and civil kind of. And
it used to. I don't know that it is now.
Okay.
So now it's computer based. You don't get your reference book, but you get a PDF reference book, which is good and bad, right? You can search it quicker, but you can't thumb to it. You can't tab it out.
Yeah.
But it's good and bad. So I didn't have to do the computer based. So like I said, I know there's changes now, but that's the main one. So after that, different states are different. In Louisiana, you can now roll from taking your fundamentals exam to your professional exam without missing a beat.
Really?
You just won't be licensed until you've got 4 years of experience under your belt.
Okay.
It used to be you have to have 4 years of work experience, then go take your PE.
Okay.
And the PE is like a repeat, 4 hours in the morning, 4 hours in the afternoon, except it's open book, 60 questions in the morning, 60 questions in the afternoon. I don't know if it's computer-based now or not, but it was open book. You can bring anything you want as long as it's bound.
Right.
It can be tabbed. It can be old tests with answers and how to work them.
Really?
As long as it's bound.
Okay.
But at the end of the day, whether you pass or fail, you still got to have 4 or 5 people that say, yes, you are competent enough to be a professional engineer and endorse you.
And do those people need to be PEs?
3 of them do.
3 of them. Okay. So the process for becoming a professional engineer that is a licensed engineer, you got to take your FE, then your first exam.
Yeah.
Then work for 4 years, and you also have to take a second exam that you said is open book. You can bring whatever books you want, and you have to have worked with some folks that are already professional engineers and get their endorsement.
Right. And the other caveat is, in those 4 years, you have to be working under a professional engineer.
Right.
If you don't, you have to be able to prove that you were doing an engineer's function.
Okay.
So if you work in manufacturing, and you might be the plant engineer for whatever, you could be the head guy and not licensed and do all these engineering functions. You got to have someone sign off to say, yes, you were doing engineering.
Okay.
So.
Yeah. So like, I never went through that process, so that's helpful. I appreciate that because, like you said, the word engineer is kind of a contentious word. It gets used in lots of different fields or lots of different places, but there's a difference between a professional engineer who is that's a certification that says this person can stamp on things that are going to get built, right? As opposed to someone who has maybe the engineering degree like I did, but I never built anything that required a stamp.
Right.
So never went through the process. And so there's differences there.
Right, and you don't have to have it to work. It helps your marketability most of all.
Definitely.
I haven't been to a company yet that says we don't have any professional engineers.
Right.
Everybody wants one, whether you use it at the company or not. Other companies can't work in other states without a professional engineer on staff to get licensed to do engineering in another state.
Yeah. So, in addition to like engineers, what other kind of people do you work with within your job?
All kinds. The most direct people are going to be project managers and designers. So project managers go and interface with the clients. Clients are, people who have projects that need to be done. If they're adding a pump, adding a new pipe rack, a new loading rack for a whole boat, whatever. They'll go speak to the client, get the scope of the job, what needs to be done, write up a scope and tell us, hey, this is what the client wants. How long would this take you to build, to design? How many hours would it be and how long is it going to take? And you give them that info and they go back and we get it or don't. And the designers are the ones who's going to be putting ink on paper. We got drafters and designers. It's kind of a two-tiered system. Drafters are people who know how to work CAD and can draw. Designers who know what to put on the paper and have been in the business long enough. Some of them are been in so long and have such experience that they're practically engineers but don't have degrees in that specific field. I work with plenty of field techs and designers who knew almost as much as me, in some cases more, depending on what level of development or where you're at.
Right. Okay. So drafters, project managers, those kinds of folks.
Designers, operations people. So design doesn't happen without talking to the people who have to use it.
Right.
Sometimes engineers try, and it fails spectacularly in their face. But at the end of the day, the operators got to use it, so the operators need to have some input.
Right.
Now you still got to limit it to, here's your time frame to give input. If you make it past this point, it's going to cost us a lot more money to implement it.
Right.
So
when you say operators, I assume you're talking about within like some kind of an industrial control system or industrial plant or somebody who's going to use whatever thing you're designing.
Yeah, so a plant, a crime lab, I've helped do one of those.
Okay, that's cool. So so the person who's actually going to be using whatever system you're designing.
Right.
That's a term that students may not be familiar with as operator.
Right.
So you've got your operators. Those are like your
kind of front line.
Your base customers, right? Yeah. Those are the people that you're trying to design for. So whenever you were saying, whenever you get that project manager to come or the person who's going to talk to the customer, that's important to get those guys' input, right?
Right. Yeah.
Yeah, I agree. Okay. So as far as how do y'all communicate with those folks? Do you usually go through email or is it a face-to-face kind of thing?
I like to go face-to-face depending on what the topic is. If there's decisions that are being made that affect the project or change anything about the original scope, it needs to be followed up in an email. It's got to be documented. So you need something to reference back to. Had clients say, no, I never said that. And yes, you did.
Right.
My wife does that to me all the time. I never said that. Here's the text. It's like, oh, whoops.
Yeah, so email is valuable, right?
Yeah, email is definitely valuable. Email is admissible in court.
Right.
One of the things that you don't see a lot, which is great for us, is the court proceedings on money that falls out from this. So if a project goes bust or whatever, or a client doesn't pay, they have lawyers that go behind the scenes and they're using all this data that you have to go through and say, nope, because of this, and this, my client's in the right, or you're in the wrong or whatever.
So documentation is vitally important for your job, right?
Yes.
Making sure that when you communicate, it's recorded and everyone understands it. That's something that you think about on a daily basis.
Oh, it's absolutely critical because it changes safety systems. It changes the cost of the project. And depending on when that happens, it could be a really big cost. Tell me a motor's going from 50 to 100 horsepower 2 days after we start. Not a big deal. Tell me it goes from 50 to 100 horsepower after I've ordered the cable and the tray and the MCC bucket that powers it. It's a very big deal.
Right. Yeah, it reminds me of a time that I was working at a plant and we were doing some stuff to the control system.
Yeah.
And part of that required us to literally turn it off. And that's something that usually you're not allowed to do, right? But we were in a plant that was not running at the time. It was being rebuilt. And so we informed operations multiple times via email that, guys, this thing will be off. You don't expect to receive any kind of signals, any kind of information. There will be no data coming from the sensors out in the field. Okay, yes, fine. And when we shut it down, everybody flipped out because there's no air sensors. Yeah. And we don't know if there's poison in the air right now. I said, yeah, guys, we told you that. And we had to go back and show our documentation. Like you're saying, look, we documented that you were informed of this. It was your responsibility to make sure that there was a safe condition for the people that were out in the field at the time. And so we didn't get in trouble because we had that proof of communication, right?
Yeah, that's the part of show your work in high school that you don't know exactly why you need to learn it, but it has real world value at the end of the day.
Yeah, showing your work, exactly. Prove to me that you said that kind of thing. Yeah, totally. I hadn't thought about that in a while. Yeah, so that's a good answer. I appreciate that. Okay, so as far as with your work, do you get to travel much?
It depends. Yes and no. So you can choose jobs where you do travel. I've done jobs offshore. I've done jobs in pipeline where I was out in West Texas and Oklahoma every month. One of my guys is another friend of mine who's an engineer is still doing that for that same company. My travel right now is pretty local, but there's some jobs like I'll go to Kentucky for some work every now and then.
Okay.
But whether you're the engineer or the project manager is going to travel more, this discipline management usually wants to be more visible and attainable by other people. You want to be present for your team.
Right.
Come ask
that makes
questions.
sense. Yeah, since you're in a management position, you want to be in the office, right? So that they can come find you.
Exactly. Yeah, I need to be found.
Yeah. When you said offshore, what do you mean by offshore?
So production platforms and offshore production platforms. I guess they're all production. So oil platforms. I mean, everyone.
Like oil
I'm sure.
rigs, right?
Yeah. Y'all saw Cars too. It's kind of like that, but not as big.
Okay. So big structures that are out in the Gulf or wherever. Yeah. Where they pull oil out of the ground and do stuff with it.
Yeah. Some of them. The first one I did was a shelf platform, so shallow water. It was like 3 miles out.
Okay.
It didn't. Some of them just pull up and clean up a little bit and then keep going. Then some other ones were, hundreds of miles out. The first one I got to help design was a floating platform, and it was massive, 300 by 300 square feet, 3 stories tall. You've got big legs that go down to this big square pontoon that keep it floating, and then they anchor it down to the bottom of the floor, and you're going like 2-3 miles down before you hit the bottom of the ocean, and then you're drilling.
Yeah.
It's phenomenal and just mind-boggling the feat of engineering that some of the stuff goes through.
Right. It's so some of those platforms out there, the fact that they're floating to me, and the fact that they can still do things at the bottom of the ocean
Yeah.
It's just mind blowing.
Yeah, and you've got pipe that goes from the floor up to the platform. You've got thrusters and stabilizers that keep it in place. They're geo-positioned within, I want to say like a meter or a few meters of their original position, held in position by thrusters from satellites, so they don't go too far. And you've got a pipe that's going down, and it can go out almost a mile from underneath the platform, and it has a tensile strength to not break.
Yeah.
And
in order to go, so I know at least whenever I was working for Honeywell, we had to do training in order to go out onto the oil rigs. Did you have to go through training to get there?
I didn't have to do Hewitt training, so I didn't get to go in the helicopter where they dump you upside down and you escape. I didn't.
That's exactly the one I was thinking of.
I wanted to. I didn't get to.
Well, unlike you, I'm a poor swimmer, so I was terrified of that idea. So I never went out on the oil rigs. But I was curious if you got to do it.
No, I got to do the swing test of the rope. They can make sure that you can swing from one spot to the other. So
okay.
When I went, I got to do 2 of them. So the three four-ways onto a platform. 2 of them are by boat. So you take a boat out, and a crane comes down with this, they call it a basket. It's a ring with some foam and a cargo net that surrounds it. You throw your bags inside, you step on the edge and hang on to that cargo net, and the crane picks you up off the boat and puts you on the platform.
Okay.
If you make the crane operator mad, you might get wet. The other option is a swing rope, where you're kind of right under the platform. They got some lower level graded platforms for you. And they swing a rope out to the boat, you grab it, and you wait for the waves to dip, and you jump, and you swing onto the platform.
That's cool.
And same thing for getting back to the boat.
Tarzan, huh?
Yeah, like Tarzan. And exactly. Next time I do it, I'm gonna holler like Tarzan. And then there's helicopters, which is why you have Hewitt training.
Okay, yeah. So
I said
that
4.
training is they have like a fake helicopter, or like a helicopter over a swimming pool, and they like flip it upside down and dunk it under the water, and you got to get out. Isn't that the training? Essentially?
That's the training. Yep, you got
to make sure
with
that
your life jacket on.
Yeah, make sure that you can swim well enough to survive an accident. Right?
Exactly.
But so how does? I assume that's not the way that they get you onto the oil rig, is by flipping the helicopter upside down.
No, they do that when they get off the oil rig.
Okay.
The old Vietnam pilots that fly those helicopters most of the time. No, they'll fly you out and hop from one to the other. A lot of the unmanned rigs, they're going to have helicopters out there.
Okay.
Yeah.
So
the
in that
helicopter
case,
pilots want to keep you out the water.
Yeah. So in that case, the helicopter just lands on a platform, and you just hop out of there.
Yeah. And the fun part is, and the Hewitt training actually comes in mostly for takeoff from a platform. Okay. So they'll hop from the platform to the edge, and they'll usually kind of dip down a little bit and turn and catch. And it's to prevent stalling. But you could stall on takeoff, and that's where Hewitt training comes in.
Okay, cool. Yeah, I was always terrified of trying to do that, just because I'm a poor swimmer. Yeah. So what are some things that really make you enjoy your job? What's your favorite parts of the work?
The problem solving, the front end engineering and design is by far the most fun part. There's a new problem. We need this, right? Or we don't know what's going on here. So one of the key things I can say to anybody going into engineering or any professional application is read 7 Habits of Highly Effective People, and start with the end in mind, or begin with the end in mind. So you have a problem. What's your goal, right? It's hard to continue working on a problem task-oriented without knowing that end goal is. You're going to figure out that solution in between, but you need to know what the goal is. And the front-end engineering and design is, here's what we know, here's a little bit, here's what we think it's going to cost. All right, you want to do the next phase? Yeah, so give me a little bit more detail. Let's refine our cost and keep going until you get to detailed design, in which case you're putting everything in drawings and telling people how to build it.
Right.
Versus, I've done my short circuit analysis. I know pretty much what equipment I'm going to buy. I've got the big picture done. I've got the block diagrams and the plot plans mostly figured out.
Yeah. So your thing that you like is the problem solving aspect of it.
Yeah, the problem solving and the conceptualizing.
Yeah, that for me too. It was always I like puzzles, right? So every engineering design problem is just a puzzle,
Yeah.
really. And I like the fact that you said you have to start with your end in mind. You ask your customer, what do you want this to actually do? What do you want at the end of the day? This to what's I'm drawing a blank here.
Yeah.
What's your end product? What do they
Yeah.
want out of this?
Exactly. If I want to make sure, what was it in our capstone design? I want to make sure they get enough ice in the cups to the proper size. Engineer me a solution. Well,
Yeah.
I can make a machine that auto dispenses it, or I can just give you 3 size of scoops that's made for that cup, right? What do you want?
Yeah.
So, what's your end goal? My end goal is I want the proper amount of ice for these cups. How much what do you want it to do in between? So we can achieve this goal. What do you want it to do?
Right. Gotcha. Okay. What about dislikes for your job?
Dislikes. Communicating with people. No. It's the hardest part of any job is communicating with people, because you're dealing with people and people's emotions, not just professionally. You're dealing with their private emotions too, because you don't know what they're bringing home or what they're taking from home to work.
Mm-hmm.
And as much as you'd like to say work is work and have work-life balance, more often than not, it doesn't happen.
Right.
So that's the hardest part. And in the management role that I'm in now, I'm having to deal with that. And I'm having to deal with interpersonal relationships between other people that I'm not involved in.
Right.
That's the sticky part about management.
Right.
On that side, is dealing with a people factor.
What do you think prepared you for that? What were some things that helped you along the way in getting better at that? Because
At management or
at management, yeah, like at dealing with the people aspect of things, or what could be some ways for students to prepare for that aspect if they expect themselves to end up in management?
Oh, geez. I got ragged on a lot as a kid by my old man. And nowadays too. I mean, he's old school. I mean,
Yeah.
He still rags on me.
Yeah.
It's all good. You have to learn not to take things personally or to heart a lot of times.
Right.
I've had people set me straight plenty of times, whether it was designers. I mean, I've had stuff this year, and I've had stuff my first year, and every year you're going to have somebody do something, and you can't take it personal. You have to grow. You have to learn to take criticism. You don't know what you're doing wrong until someone tells you. So that's the most critical part, is be ready to be wrong.
Right.
Be ready to be told you're wrong, and you need it, and improve on it.
Right.
Dealing with other people, though, is a whole nother matter. You have to learn how to, first off, you got to learn how to be a good communicator yourself with other people by yourself. Then to teach someone else and learn how to mediate is a whole nother aspect. And without books or seeing someone else do it, and it's more self-taught. They don't teach you in school so much.
Yeah. So it's something that if you see yourself going into management, it's something that you have to. It's not necessarily something that's taught in the a lot of the college curriculum.
Right.
And so that's something that we have to work on as engineers on ourselves.
Yeah, so we took business communication
Right.
in college, and I thought this was worthless. Other than we watched The Office as part of it. That was fun, but I didn't care for the business communication. I didn't care for the writing part, but technical writing came out of English too in college. All of your procrastinating in high school will pay off in this field, because sometimes you get jobs that are thrown on your desk that they need tomorrow or yesterday.
So the skill of being able to stay up late and work for long hours.
And work for long hours is something that you didn't know you were honing that you're going to need.
Okay.
But yeah, the interpersonal skills, the soft skills,
Yeah.
that you'll see on YouTube a lot about soft skills.
Yeah.
Communicating, empathizing, reading the room. I had a hard time reading the room
Okay.
for a long time, making jokes during meetings because everyone was making jokes. And then I got mine in there, but it was a little too late because they done got serious.
Yeah. Yeah.
And then-
Or it was in the that everybody's kind of going at this level and your joke's up at this level and everybody's like, whoa.
Yeah,
Yeah.
you went too far.
Yeah, you got to reading the room's a good example of another skill that you have to build especially as a manager.
Yeah, and so just even personally, because soft skills are hard to teach in school.
Yeah.
So the things you got to work on personally is your soft skills. And most people can teach you how to be a good engineer. If you can retain knowledge and learn how to learn, engineering is easily taught in your career, where the soft skills are harder.
Yeah, yeah, I agree. I agree. The soft skills, the engineering part, I used to say it's just math. Yeah, it's
math and code.
Math and code and learning logic, puzzles.
No, I say code. It's law.
Okay.
National Electric Code, IEEE, International Electric Code.
Okay, that's what you mean by see, that's another thing where your career path went and mine didn't. Was like because I was working within a plant, we followed certain regulations, but I didn't think about. Yeah.
So your networking, all the stuff that you're using, still has followed all these guidelines.
Right. Yeah. I just never heard it referred to as code.
Oh, okay. Yeah.
It was just. We called it regulations.
Regulations, standards.
Standards and regulations.
Yep.
That's what we used. Yeah. Different word for just slightly different place. Let's see. All right, we're coming close to the end here. So what's something really cool that you've worked on lately or in your career that you're proud of that you wanted to share?
The first one was Delta House, which was the big platform I told you about.
Okay.
I got to learn lighting on that one, how to do, all the lights in here, how they affect people, how the light is distributed and what the measurements are and how to calculate it out so that I can do a layout without trial and error.
Okay.
So I can select a type of light, know how many and where to place them, and then do all my stuff from there.
Well, that's cool.
And so it's that and the emergency and egress lighting and even the mood lighting and stuff, learning what color temperature is. You see that some of these lights are different colors and temperatures. This 5,000 Kelvin, that's 1,600 Kelvin.
Yeah.
And learning what all that means and where it came from, that was fun.
That is cool. That sounds really fascinating.
And I got that and get to go to conferences that are hosted by, that was Philips. I went to one for Cummins that does diesel engines and generators. I did another one with Eaton, has their own experience center, and they do distribution and controls. There's so much out there to learn. Lately, we're working on a project for an energy provider of putting a power plant on a barge in Fouchon.
Cool. Putting it on a barge. So why put it on a barge?
So that when hurricanes come in, before they come in, they can move it out. Okay. And if the infrastructure is not too damaged, they can put it in and be up and running.
Okay.
And they can also
a portable power
plant.
Power plant.
And at the same time, they're also working on microgrids around the area.
Okay.
All across the U.S. Putting in generators at local places to supply the grid.
Yeah. Cool.
Rather than building a power plant.
Yeah. Cool, man. That's exciting. Those are all neat. So if one of my students has watched this and they said, this sounds interesting to me, I want to become an electrical engineer, what would your advice be to them on how to get started? How do they start moving towards becoming an electrical engineer?
First, you got to be interested in electricity. I went into engineering because I was good at math. I chose electrical because I knew jack squat about electrical. I skipped physical science in high school, said I'm going to learn about electricity. I want to know what a volt is and what an amp is.
Yeah.
And I'm going to learn something in college, and that's why I got into electrical.
So you feel like whenever you went to college, you felt like you didn't really know much about electricity, but you were confident enough to say, I'm good at math, I can do this. Right.
I knew I was good at math, and electricity intrigued me. Right?
Yeah.
I don't know anything about it, but it can reach out and touch you, and hurt.
Right. So not knowing about something like electricity or something like that shouldn't inhibit a student from feeling like they could go to college.
No, engineering is about curiosity. And I've had family friends that had kids that are great at math. So he needs to go into engineering. I said, why? Because engineers make lots of money. I said, some do. There's good engineers, there's bad engineers. There's engineers who work in a very desirable field like NASA that's not going to pay as much as going into EPC and consulting, who has to deal with other people, and it's not desirable. It's not, you don't get to be a rocket engineer,
Yeah.
right? So what is the drive to go into engineering if just because you're good at math? So does he like working on cars? No. Does he play with concrete and dirt? No. So does he look at power lines or play with the sockets and stuff or take things apart? No. So then what's going to keep his interest when it gets hard?
Yeah. Yeah. So I really like that. Engineering's about curiosity. I haven't heard that it put so succinctly before.
Yeah.
It's about being curious about something, right? And liking to figure out a new way to solve a problem that
Yeah. Or find something new and say, hey, I can use this here, right?
Yeah.
Scientists discover things and then engineers figure out how to use it. Right?
Exactly.
So as far as, would you say deciding how to get into it, how to dive in, like I said, curiosity is first and foremost is a must to dive in. And then don't be afraid to try something new. Is when you're looking for a job or an internship. If you don't know anything about it, great. They don't expect you to. You're an intern. The best thing you can do is go research something about that job and say, I want to learn about this, 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 and this, if your manager doesn't already have that lined out for you.
Yeah.
But when you're an intern, they don't expect you to know anything. And honestly, we don't expect you to know much when you graduate. Even when they say you need to have some experience, we don't expect you to have that much. Electrical taught us so many different things at LSU. You could have gone to power, you could have gone and done rocket science.
Yeah.
Anything in between, communications. But the real world is you're not going to do all those things. You're going to pick a field about this big and you haven't learned.
Yeah.
My gooder English here, you haven't learned it all. You haven't learned all the necessary steps here. You've got the foundation, but now you got to learn how to use it and apply it in this narrow band.
Right. Exactly. I really appreciate you coming, Jared. It's good to see you again.
You too, bud.
See you around. So this was Wildcat Career Chat, episode 2. I hope y'all tune in next time.